Hey class, how you guys doing? It's Mr. Gerard here. Too bad I'm not with you. I'm recovering from surgery. I had kidney stone removed, so I'm here teaching from home, I guess. And we're here today. I'm here working with you guys on this booklet right here, Simplifying Radicals number 2. Your TOC has probably handed that out to you. And I want to go over a few of the things to get started. We'll be looking at things like area, something called Rationalizing the Denominator. So let's get started. Alright, so let's have a look at these two questions just to help remind us about what's going on from before spring break when we had left we left for our break. So square root of 12, you do that on your calculator as an irrational number, it goes on forever, and square root of 3 goes on forever. But when we multiply them together, we get a whole number here, and let's have a look and see how that works. Okay, so because they're roots, we can multiply them together, and that gets us 3 times 12 is 36. And square root of 36, as you know, is equal to 6. So even though we start off with two irrational numbers that, the decimals go on forever, there we are there with our final answer of a whole number. Alright, so let's have a look at the bottom one and see how that one plays out. Okay, so 12 divided by 3 is 4, and so the square root of 12 divided by the square root of 3 is, well, it eventually works out to be equal to 2. As we can see after this process, 12 divided by 3 gets you 4, square root of 4 is 2. So we're starting off with two irrational numbers, and through the process we wind up getting a whole number. So let's turn our attention to something that's a little bit more complicated, kind of in line with what we're talking about today. Okay, so we'll see stuff like this in your booklet, and I think this is kind of where we start off. And it's just fronter-bombering, right? This part multiplies there, and so we just have to watch how we do our multiplying. The whole numbers multiply with the whole numbers, and the square roots of the radicals multiply with the radicals. So let's see how that works. Okay, so we get that when we multiply them out. 2 root 3 times 5 root 2, and 2 root 3 times 3 root 5, right down there. And then we just, we multiply the whole numbers, and we multiply the radicals, and we try to do our best to simplify it. So let's see what we get. Okay, so, here we go. 2 times 5 is 10. Root 3 times root 2 is root 6, so that's our expression for the first part. And then 2 times 3 is 6, and then root 3 times root 5 is root 15. And so this answer here, this whole thing underneath here, that's what we call an exact value. We could calculate as decimal if we wanted to. You might want to just try it out, make sure you know how to use your calculator. But we leave our answer as an exact value. So let's see how this plays out in terms of things like area. Okay, so let's see we're asked to calculate the area of something that looks like this. That just means we take the length times the width, right? And so we'll just write a little FOIL question for us. Let's have a look and see how we set it up. Okay, so length times width, right there, length times width. So the length 2 plus root 3, the width 5 plus root 2, and that just means we have to do our FOIL, right? So first outside, inside, last, just like a regular polynomial. So let's see what that looks like. Okay, so there we go. There's our expression, right? None of these guys can be combined because none of them are like radicals, and so there's our end value. 2 times 5 gets you 10. 2 times root 2 gets you 2 root 2. Root 3 times 5 gets you 5 root 3. And then root 3 times root 2, well, 2 times 3 gets you 6, and because they're square roots, well, it's root 6. And we just leave our answer like that. The other main skill for us to do is something called rationalizing the denominator. So rationalizing means to make something rational. And so what it relates to is the idea of our square root is an irrational number. And denominator is the part of the fraction that's below the fraction. So let's look at, what we're actually trying to accomplish. Okay? Okay, so 1 over root 2, that is an irrational number in the denominator position. So an irrational square root on the bottom part of a fraction. And that's where we want to make that so that it's not the case. We want to rationalize the bottom. And it's a trick, right? It's one of the tricks that you need to learn. It'll be on your tests, and this is like the simplest example, and they do get harder. So let's have a look and see what how to do it. And it's a really simple trick. All you wind up doing is timesing this fraction by a very fancy form of 1. Let's have a look and see what this looks like. Okay, so I'm taking my original fraction, 1 over root 2, and I'm timesing it by root 2 over 2. Anything, divided by itself is just 1. So I'm taking this fraction and timesing it by a very fancy form of 1. And what winds up happening, and the reason why I chose this is because on the bottom, when I multiply those, I'm going to get root 4. And root 4, as you know, is 2. Right? So I've changed this from being an irrational number on the bottom to something that's rational. Let's see what this looks like. So I'm left with 1 times root 2 on the top, which is just root 2, and then root 2 times root 2, which is root 4. And as you know, root 4 is 2. So this finally looks like root 2 divided by 2. And so this number over here, 1 divided by root 2, if you do this on your calculator, you get the same decimal as this one on your calculator, but this one is what we call a rationalized denominator. I've taken this irrational number on the bottom, did this little trick, and now I've made a rationalized denominator. They have the same value, just this is what we call a rationalized denominator. It's like a whole number on the bottom of the fraction. So let's have a look at a couple other examples that are like that, and this is kind of like your easy version, and then I'll show you the harder version too. Okay, so I have 2 root 5 divided by 3 root 3, and if I want to rationalize the denominator, that means the root 3 here has to change, right? That's what I'm trying to get rid of. I'm trying to find a way to make that work. And so the trick is whatever the root that you're trying to get rid of, whatever, in this case it's the root 3, I want to multiply by root 3 over root 3, this fancy form of 1. Let's see. Okay, so I want to rationalize this. I want to make this into a whole number. So root 3 times root 3 is going to get us root 9. So let's see what that looks like. Okay, so 2 root 5 times root 3 gets us 2 root 15, right? The 2 stays as a whole number, and the 5 and the 3 times to get 15. And then 3 root 3 times root 3 gets you 3 root 9. And then this root 9 over here, that's gonna change teams. That's gonna become a whole number. Okay, so 2 root 15 stays on top. Oops. 3 root 9 times, so the root 9 changes to 3. So 3 times 3. So I get the whole number 9. It is now rationalized on the bottom, as you can see here, right? Whole number 9. So 2 root 15, right? 2 root 15 over the whole number 9. I have rationalized the denominator. Alright, so the second part has something to do with something called a conjugate bracket. And the conjugate bracket is a bracket that winds up giving you a difference of squares. If you can, I'll show you in a moment. But this is the second part, and this is the hardest of all the jobs. So let's have a look at what conjugate brackets are, and then the kind of questions you'll have to use to solve them. Okay, so conjugate brackets are brackets that are identical, except that one has a plus. These are binomials that are identical. One has a plus, and the other one has a minus. And when you multiply these out, something very unique happens. That's why they're kind of important. So if I do the FOIL, right, I get a times a, which is a squared, and then I get a times negative b, which is negative ab, right, that's this one, and then positive b times a is positive ab, that's this guy right there, and then I get b times negative b, which is negative b squared, that's this guy right there. And so what winds up happening is that these two parts in the middle, they cancel all the time. That's one of the properties of conjugate brackets. And we use that to our advantage. So let's see how this plays out here when I cancel them out, and then we'll use it down here on this one to do the same thing, and you'll see what happens. Okay, so up in the upper example, the positive AB and the negative AB, they cancel, leaving just a squared minus b squared, right? A squared minus b squared. A difference of squares, right? A difference, a minus sign between two squares. So the same thing happens here, right? I get, so root 5 times root 5 gets you root 25. Root 5 times root 2 gets you negative root 10. The other one gets you positive root 10. These two get you positive root 10. They'll cancel. And then positive root 2 times negative root 2 gets you negative root 4. So in the middle, these two cancel, right? Plus 10 minus root 10. They are canceled. And so what am I left with? Well, root 25, that's just 5. And root 4 is 2. So 5 minus 2 is 3. Okay, and so that's the trick that we're going to use to rationalize the denominator for the next question, something that looks like this. Okay, so here I have a denominator that's irrational, right? I got square roots in the bottom of the fraction, and I want to work to avoid that. So 3 divided by root 5 plus root 2. And what we do is we do the same trick as we did in, a couple minutes ago, but we use conjugate brackets to cancel this out. So let's see what this looks like. Okay, so remember, I'm timesing by a value of 1, right? Anything divided by itself, so as long as these two are the same, that's just timesing a fraction by a value of 1. But I've engineered this fraction that I'm multiplying by over here so that they have conjugate brackets. And so, okay, let's see what it looks like when I multiply this out. Okay, so over here, right, I've taken the 3 and I've times it by root 5 minus root 2, so 3 root 5 minus 3 root 2, that's no big deal, that's just front or bomber in. And then on the bottom, I've used the conjugate bracket, right, so this is going to be FOIL, so root 5 times root 5 gets you root 25, right? Root 5 times negative root 2 is negative root 10. You can go through them. This is going to be positive root 10, and this is going to be negative root 4, right? 2 times 2 is 4. So I get this expression on the bottom. A bunch of stuff cancels out. Okay, so the root 10s cancel out, and then square root of 25 becomes 5, and the square root of 4 becomes 2. Right now, okay, so let's have a look. Okay, so, 5 minus 2 is 3, so I get the top part. 3 root 5 minus 3 root 2, that's here. And then, 5 minus 2 is 3. And a lot of people would think that this finishes like this, but if you notice that there's a 3 common to the top and the bottom, so I can cancel out the 3's. So let's see what that looks like. Alright, so those guys cancel, and so I'm just left with 5 minus root 2. Root 5 minus root 2 divided by 1, that's a rationalized denominator. The denominator is a rational number. Okay, so that's rationalizing the denominator, and that really takes us to the end of the work of the booklet. And the booklet is designed to help you work your way through these concepts piece by piece. There's the key there, so you can check that out. You can do all of those little details that you need in moving yourself along. And this really should probably take you about a class and a half to be able to work through. Okay, so good luck. Hopefully I'll be back on Wednesday or Thursday. We'll see how I'm doing. It wasn't simple. It was surgery. So, but I look forward to seeing you. I miss you guys a lot, and I hope you guys had a great break. And we'll see you shortly. Okay, talk to you later. Bye.